Right. Right. So here we're going to start relations. So a relation is a representation between two sets of numbers, the domain and the range. Now the domain is what we call the x values. The range is the y values. The mapping now with the domain and the range, relations can be represented as what we call to be mapping diagrams. So we'll start with the different types of mapping diagrams. There are 4 types. So the first type, mapping diagrams, tells us which x values, which is the domain, are mapped onto which y values, which is the range. So your domain values are like, for instance, are always what we call the x. So I could use the letters A, B, C, D to represent the domain values or the x values. And the range is so like 1, 2, 3, 4. That's the y values. Now, there are 4 types of mapping diagrams. These are, one is what we call a one-to-one mapping. 2 is a one-to-many mapping. The third one, many-to-one mapping. And the fourth one is many-to-many mapping. So this is what we call our mapping diagram. So now let's go on to describe or try to understand each mapping diagram. Okay? Now, the first type of mapping diagram is what we call one-to-one mapping. So the one-to-one mapping, in a one-to-one mapping, each element of the domain is mapped onto only one element of the range, as shown below. So you see in all the elements, one element from the domain is mapped to one element in the range. So this is what we call a one-to-one. That is what we call a one-to-one mapping. Now, the second type of mapping is what we know it to be as one-to-many mapping. So in a one-to-many mapping, at least, and here the word I'm using, at least one of the elements of the domain is mapped on more than one element of the range. So if this is my domain, one element from the domain is mapped at least to one or more than one element in your range. So this is where, like, take, for instance, we have A is mapped onto 1 and 2, whereas B is mapped onto 3, C is mapped onto 4, but D could be mapped onto 5 and 6. So this is what we mean by one-to-one. One element of the domain is mapped onto more than one element of the range. All right. So now we can proceed on to many-to-one mapping. So with a many-to-one mapping, in a many-to-one mapping, this is how we will describe a many-to-one mapping. So we will write, in a many-to-one mapping, more than one element of the domain, more than one element of the domain is mapped onto at least one of the elements of the range. As shown above. All right, so that's what we want to be a many-to-one mapping. Next one we're moving on to, so you all could see that a many-to-one mapping is where one element, more than one element. So you see now how from A could be mapped onto 1, but B can be also mapped onto 1. C could be to 2, D to 3, E to 4, But F could be good, and G, F and G could be mapped onto 5 and 6. So that's what we term to be many-to-one mapping. The last one, and the fourth and final one, is what we term to be many-to-many mapping. All right, so this here, this is my domain, and this is the range. So many-to-many mapping in a many-to-many mapping, more than one element, more than one element of the domain, more than one element of the domain is mapped onto one element of the range. And one element of the domain is mapped onto more than one element, more than one element. Oops. More than one element of the range as shown below. As shown, well, I hope it fits below. So this will be A, B, C, D, E. And here I could go 1, 2, 3, 4, 5, 6. So this is my domain. And this is my range. Right? So therefore now we're going from A, which is 1 to 1 and 2. A could go from 1 and 2. B could go from 1 and 3. So you have to look at this. B can go from 1 and 3. 1, and it could go to 3. C could go to 3 and 4. C could go to 3, and it could go to 4. Right? So you see what's happening here? C can go into 3 and 4. And lastly, we could have D could go to 5. D could go straight to 5. And in addition to that, we could have E could go to 5 and 6. All right, so I'm using a different color for each. So E could go to 5 and 6. So these are the 4 types of mappings. They are one-to-one, a one-to-many, a many-to-one, and lastly, what we have is a many-to-many. These are the 4 different types of mappings that we use in relations. Okay? And you need to know about these types of mappings. Why? Because when you see multiple choice, in multiple choice, they usually ask about these type of mappings. What is a one-to-one mapping? Identify a one-to-one mapping. They'll give you diagrams and tell you to identify many to one. They don't like many one-to-one most of the time because it's easy to identify. You will mostly see they will use things like one-to-many, one-to-many, many-to-one, and many-to-many mappings. These are the different types of mappings they like, especially for multiple choice. Good with that? Yes or no?
Yes, ma'am.
Yes? So we're going on to, from relations, we're moving on to something called functions. Because functions are relations that related to each other. All right? You all tell me when you all are ready. All right, are you all ready? Yes or no? All right, so ready for functions? Can I move on? All right. All right, let's go. Let's topic is functions. Topic. Functions. A function is defined. So a function is defined as a relation, in which each element of the domain, each element in which each element in the domain is mapped onto one and only one element, one and only one element in the range. So function is defined as a relation in which each element in the domain is mapped onto one and only one element in the range. So you got to note this. Note in a function, each x value can have only one corresponding, but that's what I have up there, corresponding y value. However, a y value can have, more than one corresponding x value. So in a function, each x value can have only one. And here it is, only one corresponding y value. However, y value can have more than one corresponding x value. So it means to say that a function can be a one-to-one. It can have a one-to-one mapping, and a function can have a many-to-one mapping. So that's how we determine these are functions, right? So a function can have a one-to-one mapping, or it can have a many-to-one mapping. So this is what they have in the multiple choice. They ask you to determine what is a function. Majority of times they like to show many-to-one, just to confuse you. Sometimes they will show a one-to-one and you all immediately will know off the bat that is a function. But most of the time they like to use many-to-one mapping for you to identify that is a function. Okay, so you all see what is a one-to-one. A many-to-one can be in the form of a quadratic, but what we term to be quadratic graphs. So a many-to-one, so I should give you all diagrams of functions. So the mapping diagrams of a function can be as follows. We could have a straight line graph will represent a function. And this is one-to-one. I should write it. So this is my x, this is my y, and this is my straight line. So that is my function. A straight line can be a function. The next thing that can be a function will be what we term to be a quadratic graph or a parabola. These are all functions. So this is A. I'd like to show you all the other graphs that could look like functions. So when you're finished, copy this down. I will move on. So to show you the other types of graphs that you can draw to represent functions. So in case you see it in a multiple choice exam, you all immediately will recognize that is a function. And I will show you all a graph that will indicate that it is not a function.
Miss, I see that when I was going on lessons for the vacation.
For real, you saw that?
Yeah. But
Wow.
it was looking hard, but easy.
All right, so can we go on to, can I show you all the other types, other diagrams or other graphs mostly? The graphs that represent formats. A short thumbs up, so I'll know. All right. All right, so the next one, I'll turn any page, you guys. Can I turn the page? Yeah. So the next type will be parabola or quadratic graphs. Parabola or quadratic graphs, as we will call it, quadratic curves. Okay, so this is what you all will do. So let's see now. So it can be in the format, I'll show you. So this is my X, this is my Y. So it can be in this format, like that. Or this is what we call a maximum, or it can be like in this format. Right. Y and X. All right, so it will be like this. So here be 0, here be X, here be Y, and that's how you get it, like that. That's B, parabola or quadratic curve or graph. And the next one, C, which is what we call a cubic function and a modulus function. So this is how a cubic function looks like. Probably first time I hearing something like that. Cubic and modulus. They usually use this in AddMaths. So whoever wants to go on to do additional mathematics, or if you're doing it right now, you all will meet up something called a cubic function. This one is what we call a cubic function, right? Cubic function. And the next one is what you call or modulus function. So your modulus function is like this. This is X, this is Y. 0 to be like this. and it's like this. All right, so that's what we call a modulus function. So this is cubic function, modulus function, parabola, or quadratic curve. So take that down. So all this is just, how should I say, knowledge base. That's what it is basically. Mainly knowledge base, which you could be able to use when you are doing your multiple choice. So all this is basically knowledge base. I'd say, to me, it's one last thing to show you all graphs that do not represent functions. So if you see these graphs in a multiple choice, you will know that these do not represent functions. I'd say, Tammy. All right, can I move on? Yes or no? You all hearing me? Yeah?
Yes, ma'am.
Okay, cool. I'll just
Don't change
checking.
it as
Don't change it as yet. All right, cool. I wouldn't change it as yet. Right, so let me just I'm gonna just pull. So the following graphs, so we're going on to the following graphs do not the following graphs do not represent functions. Do not represent functions because the x values have more than one corresponding y value. Okay, so that's what it is. The following graphs do not represent functions because the x values have more than one corresponding y value. So for instance, let me show it. If your graph looking like this, okay, I think I need to turn it to the side. And if I can make it accurate, yes, I think I can. So if the graph looking like okay, cool. And let's see from here. Right. That's one. And the other one will look like this. Let's show you all that. This is my X. This is my Y. So here it will be 1. And here will be the other one. That is what we call, these are not functions. So if you see a graph looking like that, you know they are not functions. You hear me? If you see in the multiple choice, they give you graphs looking like what you see in here, either this or this, they are not functions. Okay? All right, with that, yes or no?
Yes, miss.
All right, so we will still go on because we need to start off with all of this set of knowledge that you just gained and everything. So, you know, we all probably say this is our English class. Only English class have a lot of writing in it. So let's move on to now go doing the real math class, and that is solving simple functions. Okay? So this is solving simple functions. All right. Ready? Let's go. Oopsie. So if we're starting, if x is mapped onto f of x, that's how we pronounce it, then we can substitute any value of x into the expression, for f of x to find the corresponding value of f of x. So we got a note, x, this symbol fx means x is mapped onto f of x, where x is an element, where x is an element of the domain, and f of x is an element of the range. So x is an element of the domain and f of x is an element of the range. So then we will start off with an example. Example. Given fx is equal to 2x plus 5. Find Part 1, f of 2, part 2, f of -3, and the last one, part 3, f of a half. Right, so y'all tell me when you're ready, so I could be able to turn the page. All right, can I turn the page? Yes or no? No or yes? All right, so y'all can put a thumbs up so I could be able to know. All right, great. All right, so I'm going to turn the page, and here we're going to learn to solve how to solve functions. We're gonna do some functions today. So here the first question. The first example is, we see that f of x is equal to 2x plus 5. The first part is f of 2. What is happening here is that we are replacing your x value in this function that we have. The function is 2x plus 5. So we are replacing the x value, 2x plus 5, with the number 2. So we no longer having an x here. We are going to put it as 2. So this will be f. If I put, 2, if I put 2 and I put a brackets, some children prefer brackets, which means multiply. And then I'll put the number 2 and then plus 5. So 2 2s are what? 2 2s are 4 plus 5. So your answer is 9. So f of 2, the answer it is 9. In this situation, what I'm doing, I am replacing the x value in the function 2x plus 5 with the number 2. Do you all understand that? Yes or no?
Yes, miss.
Yes or no? Okay with that? Yes or no? All right, so can I go on to the other part? Yes, miss. All right, so all right, ready? Okay, so let's go with the next one, f of -3. F of -3, this will be 2. Instead of the x here, what I'm going to put now is -3 plus 5. So this will be 2 times -3 will give me -6 plus 5. So f of -3 will give me -1. Okay with that, y'all? Yes or no?
Yes, Miss.
Mm-hmm. Well, I know you all don't like fractions. Who likes fractions? You like to eat fractions because fractions is in terms of pizza. Pizza is represented, the slices of pizza is fractions. Well, that's the only time we probably like when it is a fraction. So, but this now, functions also have fractions. So f of a half, same process. Instead of the x in the function 2x plus 5, we are replacing it with the half. So it'll be 2 by a half plus 5. So 2 multiplied by a half, the 2's will cancel out. You remain with 1 plus 5. So 1 plus 5 is 6. So this will be f of a half. So do you all understand that? Yes or no? And this is what basically functions in solving functions is all about. You know, when you hear the big word function, you're thinking all sorts of things. But functions is basically really replacing the letters with numbers. That's what really function is all about. I am replacing all my letters with a number that is given. So suppose they give me my function is f of x is 2x plus 5. So therefore now they want me to find f of 2. I'm going to replace all my x values inside of here with the number 2. They give me another thing. They say f of -3. I'm going to replace all the x value inside of here with the number -3, and so on. And that is what it is basically about. All right. Now we can get complicated. Like if you're given an example like this. So take down this example. Example 2. If f of x is equal to 2x squared minus 3x plus 1, find the values of 1, f of -3, 2, f of 0, and 3, f of 2. Now you could get like that. So take down that. Ready? Solution. So no matter what, if you see a x, you replace it with the numbers here that they give us. So the first one, f of x is equal to 2x squared minus 3x plus 1. So here we want f of -3. So what you will do, I will replace my letters with -3, right? So what you're going to do, replace the letter x with -3. So this will be 2 by -3 all to the square minus 3 by -3 plus 1. So -3 to the square, -3 to the square is equal to -3 times -3. Negative by negative is a positive. 3 3s are 9. So this will be 2 by 9. Negative by a negative is a positive, and 3 3s are 9 plus 1. 2 9s are 18 plus 9 plus 1. So the answer here will be 28. So that's how you'll get f of -3. Okay? So say that, yes or no? Do you all understand how I got that? Yes or no?
Yes, miss.
Okay, I'll take it down and I'll need to go on the other side, on the other page. So can I move on to the other page?
Yes,
Because remember functions is really and truly, we are replacing our x value with the number that they gave us. That's what it's basically doing, you know, replacing. I mean, and they like to use the big word substituting, but you're really replacing, you know? All right, so let's go number 2. Number 2, it is f of 0. So we are replacing in this function all the x squared now with the number 0. So this will be 2 by 0 squared minus 3 by 0 plus 1. 2 times 0 squared, but anything times 0 is always 0. Minus 3 times 0 is 0 plus 1. So f of 0 will be equal to 1. All right, so f of 0, the answer is 1. Okay, so we're going on to number 3. F of 2. Replacing the x value with number 2. So this will be 2 by 2 squared minus 3 by 2 plus 1. How will you get 2 squared? 2 squared is equal to 2 times 2, which will be 4. So this will be 2 by 4 minus 3 2s are 6 plus 1. 2 4s are 8 minus 6 plus 1. So you get 8 and 1 is 9. All right, 9 take away 6, answer is 3. Any questions about this? Yes, no? So this is when you're getting a little more, how should I say, a little more, well, challenging. All right? Do you all understand this? Yes or no? Yes or no? So I'm going to give you 2 questions to do now. So this is my question. My question is, if g of x, first one, if g of x is mapped onto 3x minus 1, find the values of 1, a, g of 2, and b, g of negative 3. Next one, number 2. Given the function f of x is mapped onto 3x squared plus 2x minus 1, find part A, f of 0, f of 0, part B, you're seeing that? Oh, that's not looking jumbled up and fuzzy looking. Okay, I will write over this. So part A, you'll find f of 0. Part B, f of 2. And part C will be f of negative 1. Next one, number 3. F of x is equal to x squared plus 5. Find part A, f of 1. Part B, f of 2. Part C, f of 4. Okay, so I want you all to do questions 1 and 2 now. Number 3 will be for homework. 3, 4, and 5. I'll put them down. All right, so do 1 and 2 now, please.